Yeah, it's your boy Chill here. Welcome back to Chill. Today we are wrapping up our little story arc here that we've been doing, making an expressive CLI framework. In the last video, I mentioned we had a little bit of an existential crisis. So what was I talking about there? Maybe you've guessed it, but let me just show you. We're going to compile just main.cpp here, and I'm not going to cut any of this out. Still going. Still going. Oh, here we go. 15 seconds. Okay. So 15 seconds to compile one file here. And I mean, you know, you might say, well, you got a lot of stuff going on in here, Chili, but that's cope. That is cope. So let's do a little experiment. All right, so I made this little CPP file here. Very minimal. Just include a few headers that I usually include in all my source files. Little function here, and I include cli.hpp. Now let's compile this bad boy. All right, that takes 10 seconds. 10 seconds to compile this file here. What if we remove cli.hpp? It takes 1 second. 1 second. Yeah, you include CLI and you're 10xing your compile time in every translation unit that file touches. And you're probably going to be including this CLI stuff in a lot of your files. Any file that is going to want to access those parameters, it's going to include it. So this is going to blow up your compile time. And this is a problem that you have with libraries like these. Like it has a rich feature set. That's great. I love it. I love the slick interface that it gives you, but it's header only. Header only is very nice. It's very easy to include in your project and link to it because there's no linking. But that means you have to compile the entire thing every time you compile anything in your program. And for something that is as complex as CLI 11 is, because it has a lot of features, that blows up your compile time. And I mean, I'm not the only one who's had this issue. This has been around for years. People have talked about it. But it's still, it's nothing has changed. So what can we do? Now, normally, the thing that I would do in a situation like this is, okay, I would try to isolate it. I would quarantine it. So I wouldn't include CLI 11 in the header file, only include it in here. And I would forward declare things like app and, you know, reference them via a pointer, basically the pimple idiom. And I mean, that would work fine for something like options container base. Because look at all the functions that actually access the details of app. They're already quarantined into their own translation unit. So I could turn this into, you know, like a shared pointer or a unique pointer, forward declare it, and then not include this. And that would work fine. But if we go down to something like here, an option, it's templated, and it's calling this function add option, which is also templated. This is, look, it's a templated function. So because it's a templated function, you can't move it into the CPP. It has to be visible where it's being called. And that's a problem because now if you want to be able to call this one in the header, that means you got to include CLI 11 and blow up your compile times. And I was really grappling with this problem because I was like, I love this system that we've created, but I can't see myself, you know, adding, like, as this thing grows, like we might be adding like minutes to the compile time. That's terrible. There's a certain point where I just can't justify it. So your boy Chili got serious. He went into the lab, and I have theory crafted a way that we can quarantine the compile time cancer of CLI 11 out of our system. So what we have to make some observations here. We have to observe the thing that is really preventing us from forward declaring is we're calling this templated function. But when does this function actually get invoked? Does it get invoked all throughout the code? So most of the places in your code base, you are just accessing these members to read them. This code is only being invoked when you construct this, and so you're constructing all the sub members. So if we can quarantine the construction part, isolate the template out of that somehow, then we can basically put all that code in a single translation unit, a single CPP file that only gets compiled whenever you change these things. And the rest of it forward declare, and we can remove this inclusion from our header, which means it doesn't get included here, which means it doesn't get included all throughout our framework and throughout, you know, the end developer's application code. So that is a tall order, but we can do it. We have the technology. We are going to hack the compiler. So the current system we have here is we got it split up into two layers. The CLI framework, where we put all the boilerplate, and then the app usage, where they define their actual, their structure with all the options. And of course, this one is going to include the framework, and we can offload some of the functions that don't depend on template stuff. We offload them into the CPP. So this CPP file in the framework depends on this header, reduces the compile time a little bit. Now we're going to have to make a change here. What we're going to do is we're going to take all the template stuff that depends on CLI 11, and we're going to put it into a special file. We're going to call this an IP file, IPP, for inclusion. So this is going to depend on H. It's going to include the .h. It's not a translation unit. It doesn't get compiled. We have to get the end developer to do an extra step. They also have to create a CPP file for their options. And that CPP file is it's simply going to include this IPP. And this is going to have now the single definition where all this CLI 11 stuff, all the template stuff gets built in. And in here, we are going to sequester the construction stuff so that it doesn't get externally referenced and we don't end up with missing dependencies. So this CPP is also going to depend on this header. It's going to include the header so that it knows about the shape of this data type, the structure, and the construction will happen in here, and we'll just have a function that we can call, and the outside world will not have to bind to CLI 11, and our compile times will get amazing. So we're going to create a file here, CLI-framework.ipp. And essentially, we have to move everything in here that is going to reference CLI 11 details, unless it's already in CPP. If it can be pulled out into CPP, we put it in here because that's the best option. But anything that can't get in there, it has to go into here. So CLI 11 framework. So we're not going to include wrap CLI in here anymore. We're going to include it in here in the IPP file. Now we're going to be missing definitions of anything in CLI. So allow us to forward declare some stuff here. One thing we're going to do for our first little pass here, we're not going to worry about getting the rules or, these customizers ported over. We're going to comment these out to begin with. We're just going to focus on the elements here. Now, like I said, the beauty of options container base is it doesn't actually access any details about CLI 11 in this header file. So all we got to do is just reference this thing by pointer instead of referencing it, like including it directly in the object. So we're going to include memory so that we can use a smart pointer for this one. And we're going to use a shared pointer. You might think, why don't you use a unique pointer? The problem with using a unique pointer is the destructor. It wants to statically bind to the destructor, and that causes problems. There might be a way to get around it, but it's very annoying. A shared pointer can type erase the destructor function, so it's much better isolation of the CLI 11 details. So we change this from object to a pointer, so that's going to break a bunch of stuff in here. So we just do like p app underscore pointer to name. Why is it not happy? Probably because we have to include CLI 11 in here now. We need the definition. So wrap CLI 11 comes into here. You should be happy. And then we just got to fix the other guys. All right, that's pretty simple. Options container. So none of these things really access the details of CLI 11. So they're fine to stay in this file here. And many of them have to stay because they're going to be accessed from the end client code. But this one, this is where T actually gets constructed. This has to be quarantined into the IPP file. So let me copy this, get rid of that, and we're going to go into CLI framework.ipp. Here's our first item for quarantine. This one is going to look like this. Declare the template in the IPP. So far, so good. Now, the option, P option, it's already being accessed as a pointer, so that's fine. Don't have to do anything there. The base is not templated, and it already is putting all its definitions into the CPP file, so it's fine. So all we got to do now is this constructor, which is templated, has to be moved into the IPP because it's accessing details, it's templated, no bueno. All these ones down here, they only access the data, so they have no problem staying in this .h file. Actually, I realized there's something I missed here. So before, when we had the app directly embedded in here, the default constructor was just doing the stuff automatically. But now we gotta add some sauce. So we gotta add our own customized default constructor, and that's gonna call make shared to create the app. Okay, there we go. Little backtracking there, but we're all fine. So we gotta migrate this guy. We gotta put him into the IPP. So let's copy this, a little annoying, put this one in here, option, and this is a template class, template function of a template class. So we need to add another template here for the T, and then this one has to be specialized on T, and then it should be sort of happy, except you probably don't want to put the default one in there. Okay, now we're cooking. Go back here, can delete this implementation code because now it is being implemented in the IP file. All right, so that is option, quarantined, and flag. The beautiful thing about flag is that its data type T is always a boolean, so it doesn't really have templating. There's a little templating here for the customizer, but we're not going to be using customizers to start, so let's just comment that out. We'll just remove that option, and that fixes that. And I think that should be everything. That should be the baseline to do our little proof of concept here. So minimally, we only had to really quarantine these two functions into our IP file. All right, now in CLI options.h, obviously, you know, this customizer stuff and these rules aren't going to work because we commented them out. So let's comment them out here as well. And we're just going to reduce our options here. So this one, because it has a customizer, this one has a customizer. The rest of these should still work. Now in main, this one is not existent, so we should comment that out. Okay, now here's the secret sauce. Pay attention to this part. We're going to add a new item, CLI options.cpp. And what this one is going to do, we're going to include CLI options.h, and then we're going to include CLI framework.ip. And now this is the one place where definition of this one and this one is going to be generated. Now, here's the thing. In main.cpp, when we call get, that is going to call this one, which is going to try to call the private get, which is in our IP file, and that is going to result in a linker error because it won't be able to find it. We have to tell the compiler, this is very important, we have to tell the compiler to instantiate the definitions for options container to put a one definition in here and then use that everywhere. Now this is a special case that we have here. The special case is that the options container is only ever templated on one type T, and that one type is the type defined here, our options type. So because there's only one templated type, it's not instantiating a bunch of different ones in different places. We know the one type, so we can lock it down in here and tell the compiler use this definition that we're going to put in here. So here's the syntax for that. Template class chill CLI options container, and then templated on CLI options. And that's all you got to do. And doing that is going to make sure that the compiler generates that in the CPP file, and all the other files at the link time, all the other references to the get function, the private get, will work in here. References to these two things. This get is the only thing that is going to be externally linked because this one is being called when you call this one here. So it's going to only be, this linkage is only going to be internal to the CPP file. So here is the secret sauce. Now the question is it going to compile? All right, minor issue here. Looks like we forgot to change from app to papp. So we're returning a reference here. So we should do papp and then put a star there. All right, let's see if that fixes it. All right, we have success. We have successfully built. And now let's do our little test here. So now we've got this test. Well, let's just try to build main. So before it took 15 seconds. Now how long is it going to take? So now it takes about 5 seconds. So we shaved 10 seconds off, which is about what we would expect. And again, if we try to compile this one, while including our CLI framework. And let's even make it use something from the CLI options there. So 2.3 seconds. Pretty dang good if you ask me. We have definitely shaved down. This is an acceptable level of compile time in my opinion. All right, now we just gotta bring over the bells and whistles again. We'll start with the rules. So all of these only get invoked on construction. So we can easily move them to the IP file and everything should just work. So let's uncomment this. These implementations, there's nothing template about them. They can go in the CPP file. These ones have to go in the IP file because they're templated. Well, not this one though. This one can go in the CPP. So now you can see these functions that were previously accessing the details of CLI 11, they've been moved into IP file or into the CPP file as necessary. These ones here, they only access the other templates, so I didn't even bother moving them over, although I probably could. So that is the quarantine of the rules. Now, the validator, customizer is going to take a little more work. Let's just start with the rules. So because I did that, I should be able to uncomment this, and I should be able to do a full build without any errors. Yeah, and that works fine. We have our rules back. Now, the last thing we need is our customizers. We can't really work with validators directly in the header file now because that would require us to include CLI 11. It is verboten. So we have to type erase validator stuff somehow. So what we're going to do is we're going to put this all in its own namespace, like I said before. Namespace cust. And we're going to create a type that will act as the type eraser for all kinds of customizers. So create our class customizer in here. Let's define this before we define option so that the definition will be available there. We can remove empty customizer. It's not going to be a thing anymore. That's not a thing. Now let's go up here and include functional. So we're going to use std function as a type eraser. It's one of the main reasons why it was introduced is for type erasure purposes. It's going to be std function. It is going to be void taking in CLI option pointer to. Option pointer. We'll just call it function. I don't know. The baseline constructor, very simple. It just takes in anything that's a callable function with an option pointer. And we'll even default it to just an empty function that does nothing. And that's what's going to replace our previously, empty customizer. That's the replacement for that. So we've got this customizer here. Option, very good. Let's add a couple more things here. We'll add the ability to combine two customizers into a single customizer. So if you try to combine two customizers with the pipe operator, it's going to create a new customizer that's a composition of both of them. And a very simple way to do that is to just create it with a new function that captures both of the functions of the previous customizers and then calls them both in sequence. So here's how you can compose customizations. And the last thing we're going to add in here is just an invoke function where you supply it with a pointer to an option. It calls the customizer function on the option. So this is how we're going to wrap customizers, primarily CLI validators. So now what we have to do is you have to create a bunch of factory functions that create customizers wrapping all of the validators that are available in CLI 11, and that's what's going to expose those to the end user. And the beauty of this is it actually now abstracts them away from the CLI 11 details, so they don't have to understand CLI 11 to use our thing. And it also gives us the option of perhaps switching CLI 11 out with something else in the future without breaking everyone's existing code. So we'll start with a simple one, customizer existing path. Just create a function like this, very simple, and then we implement it in the IPP. So we put this namespace here in the IPP. So we're going to return a new customizer. Lambda function has the required signature. Use the POP that was passed in to call transform, and it's going to pass it the actual validator that's implementing this under the hood, which is going to be CLI, I guess existing path is the name of it. Yeah, it's just existing path. That's an object, so we don't even have to construct it. And there you go. So now if we go to CLI options.h, we should be able to do an existing path one. Well, I guess first we need to change how our options work to use the new customizers. So now this doesn't even have to be templated. This can just be customizer. So in here, now it's not template, it's just customizer. And we can default it to this, which will create just an empty function that does nothing. That's great. We no longer need this part of the template. And now we just got to do it, which is to say, no matter what, we're always going to call customizer.invoke with the P option. This should simplify things also for the flag, because this templated version does not need to be supplied anymore. We just put the optional customizer in here. This is not templated, so it doesn't have to go in the IPP. And then we call invoke with the P option. There you go. Flag has been set up to use customizers. So now if we go back into here, works better if we pass it null opt for this one here, but cust existing path, and that's a function, so we call it. That creates the existing path customizer in here. All right, so let me just make sure that I've got path windows up here. A little bit of syntax errors for you, just to spice up your life. Probably want something there. Probably want something there. Could even use brace initialization for this one here. All right, try again. And that seems to work. If we run it, no problem. What if we give it a non-existent path? Path does not exist. Okay, so that is the customizer proof of concept working. Now the only thing is we've got to do that. We got to make one of these for all the customizers, all the validators that we want to expose to the users of our framework. So there's a few of them. And this is a bit of boilerplate here. I don't want to repeat this boilerplate code for every single customizer that we're creating a factory for. So let's do a little kind of private namespace, unnamed namespace here. And we're going to make a little adapter function. So our adapt function takes in a CLI validator and wraps it up as a customizer. So now we can take this existing path, replace it with this. So here, let's add all the non-templated validators that are in CLI 11. So here's all the non-templated ones that I think are going to be useful. I think they're pretty self-explanatory. This one checks to see if it's an IP address, non-negative number, positive number, etc. And in here, those simply become this. So a very clean way of basically forwarding these to the end users of our framework while type erasing them and quarantining the CLI 11. All right, let's add some customizers now that are templated. So there's two basic ones. You've already seen me use range. It just makes sure that the value is within some range. Clamp is similar, but it adjusts the value. So it will clamp it to be within the range. If it's too low, it'll increase it until it goes up to minimum. So these two templated on type T, because it could be a double, it could be an int, could be a float. Now, interesting about these ones is they don't have a pre-existing object because you have to construct it with the actual values. So let's add another adapter up in here. So what this adapter is going to do is it doesn't take in a validator object. It takes in arguments, and we have a validator type. It'll construct the validator with those arguments, and then it will do the same. We could just actually call into adapt from here. Yeah, this is cleaner. Construct the validator and then call our other adapter, which will create the wrapper. Okay, that's beautiful. And if we do that, we can implement range like this, call adapt. We want to create CLI range with min-max parameters. Same story for clamp. In CLI 11, it's called bound, but I think clamp is a better name, so I'm using clamp. All right, the next customizer we're going to implement is called in. And this one, you give it a list of values, and that's the values that are allowed. So you're basically whitelisting values. And so you can do it with an initializer list or just any container. The CLI 11 validator for that is actually called isMember. I like in better. But you construct that, you give it the container, and you can give it a customizer for things like whether it should ignore case, which is one option that we've exposed through our interface here. Now, what I normally do, what I've done in the past, is I just do like a ternary here and I pass in ignore case or not, but I don't like this. So we can create a customizer that just does nothing, and that'll make our life a little easier. So we'll do std string null modifier. I don't exactly remember what these things here, they're just functions. So if I go to definition here, yeah, it just takes in a string and it returns a string. So we can do null modifier and it just does nothing, right? And then here I'm just gonna do ignore case question mark. If so, we pass in ignore case. If not, we pass in null modifier. And that should work. And then for the version that takes an initializer list, we're just going to construct a vector container out of that list and forward it to this one. And finally, we have our favorite customizer, enum map. That's going to be doing some magic enum stuff. We can actually move magic enum out of here now, put it in the IP file. That is going to improve compile time a little bit. And that's going to look like this. We have our familiar sexy ranges stuff that's going to generate our map. And we adapt the check transformer with that. And there we have it. These are the most, I think, useful validators, all exposed through our interface here. There's a few more that you could add if you want, but I think this is good for now. So let's reinstate some of these ones that we had disabled. Yeah, we got a problem. Null modifier must return a value. That makes sense. Fix that. And we have success. Let's do a quick little test here with the help. See what we get. And yeah, we got our dinkum enum, and it's got all the mappings of the characters in there. All right, let's do one final full-on test here. We are going to test two things at once. We're going to test our customizer in, so we're only going to allow specific members of the enumeration, and we're going to combine that with the enumeration map dinkum. All right, this gives us an error, and I was prepared for this. There's a little wrinkle in here. We're giving it this the modifier for ignore case, or just a modifier that does nothing. We're passing that in here. But if the container T, if this isn't a string thing, if it's like integers or whatever, this modifier isn't going to work because it's taking in strings. So it doesn't apply. So we'll do bool ignore case. So it's got to go in the template part here. And then we got to do if const expr ignore case. Otherwise, we just got to call it with nothing at all, except for the container, of course. We got to do the same for these guys down here. So we got to move the ignore case in first because we want type name T to be deduced. So for a num map, we should actually put the ignore case second because it's expecting the first one to be the template parameter. Yeah, that makes sense. All right, let's switch this around. Okay, and finally we have it all working together. That wasn't annoying at all. So now if I run it with help, it's going to say dinkum enum value, and it's going to give the mappings, but it's going to say that only 0 and 2 are actually valid. So if I supply chart, let's apply smart, and let's make the case a little messed up. Works fine, because we have ignore case on the mapping here. Now, what if we were to supply fart, which is not in our whitelist here? Dinkum. 1, not in 0 to 2. So it doesn't give you the text because it does the transformation first, but still you can combine your whitelist with your enumeration string maps and supply a string and have it be filtered by the whitelist. Very nice. Now I wasn't expecting this little issue. It's annoying in here to have to specify false. We never want to turn the ignore case on if the type isn't a string type. So we can use template metaprogramming to automate this so that we don't force them to supply false for these ones. So we just want to be able to do it like this. All right, so here's the plan. We got this T here. This is going to be a container. If the value type of its elements is not a string or a string literal, we are going to force ignore case to false, regardless of what was passed in here. So we need to get the value type. And we can do like type name. We need to remove any kind of reference or anything. So let's do dkt. And from that, we get, I think, value type. Let me just double check that. Value type is the type def member that we have access to. Ignore case override is equal to, so the value type is string, or the value type is const char pointer, then we yield the thing that was passed in. Otherwise, we force it to false. And then we're going to use ignore case override here. And now this should override it so that we don't have to pass in anything in here. It will automatically go to false because these things aren't strings. Well, a little bit of syntax brain fart there. And there you go, template metaprogramming to the rescue. As long as you're willing to suffer some brain damage, you can make the interface even a little better at the cost of your own mental. But yeah, this is pretty much now perfect. Exactly everything that I wanted. So all in all, it's been I think it's a very successful addition here to our framework, and I'll be using this going forward when I'm, doing tests on the graphics subsystem. And in all likelihood, that's what we're going to be continuing on in the next video. We're going to go back to the graphics, and hopefully I will have something down to move forward. But until then, thanks for watching. Hope you enjoyed this little descent into metaprogramming madness. If you did, please click the like button, it helps a lot. And I will see you again with some more chill.